have to lecture at university. Okay, so I'm starting with a bit of delay. I'll try to speed up a bit. I'm going to talk today about Janus and Janus performance in particular when it comes to using the ICE stack, Interactive Connectivity Establishment. I'm quite pleased about the results that Ludo just presented, and I have to say that my talk is quite in line with what he already presented because I'm focusing exactly on some of the figures that he was illustrating to all of us that are related to Janus scalability. So this is just Janus. It's not other SFUs or the likes, just focusing on our own stuff. My name is Simon Romano, and thank you, Vijay, for the introduction. So just a quick recap on Janus. Where does it come from? Actually, we founded a company that is called Mitico or Miteco, as you prefer. We are going to party our 10 years, March 2019. Miteco is an academic spin-off. I'm an academic professor, and the guys who work for Miteco are all former PhD students at the University of Napoli, and now they are running their own business. Napoli is this lovely town in southern part of Italy. We started by focusing on real-time multimedia applications, and then WebRTC came to the fore. So we started to work on WebRTC, obviously. Janus, the idea is that we have this double-phased component which looks both at the past and at the future. We started with this. That's why we called it Janus. And the idea was in the beginning to somehow provide people with a gateway that should allow WebRTC applications to work seamlessly together with WebRTC components. Actually, nowadays, the gatewaying part is the least important for us. We are just focusing, we are mainly focusing on WebRTC to WebRTC communication, even though you can leverage Janus if you want a gateway. It's an open source project. Everything is on GitHub, and we have, I would say, a very large community now that is contributing to Janus. Who is using Janus? We are using Janus ourselves. As Vijay was telling you, we are providing remote participation facilities for the ITF community, but it's not the only thing that we're doing, actually. We are providing support for most of the ACM conferences, the flagship conferences all over the world since 2 years ago. And just to give you a flavor, this is, for example, what happens at the ITF meetings. We are streaming 8 sessions in parallel all the time. It's a huge work. We are doing this from a single montage room that is located at the NOC, the Network Operations Center. We do things like that. So this is a remote participant there. We allow people to interact with the room. So it's not just streaming. It's bidirectional interaction with the room in real time. We are also providing recordings for what we do. So it's quite a complicated set of functions that we are providing to the community. Many other people are actually using Janus for many of the things that you can read through in this list. We go from, let's say, e-learning to gaming to IoT-based applications to surveillance systems, even many more ways of using Janus than we were expecting when we started this work. Just to give you an idea, also Microsoft is using Janus. Many of the services behind the Xbox now leverage Janus. So we're quite proud of that. Slack was using Janus, and I don't know, they are claiming now that they are changing, they're developing a homemade new component, but up until a few months ago, they were using Janus. So what I'm focusing on today is Janus scalability. Obviously, we were interested in working on that because we are providing more and more deployments of Janus in cloud-based environments where you need more instances of the component. So we started to somehow analyze the behavior of Janus in the presence of a number of participants. And we decided to focus in the beginning on a single instance because this is going to act as a sort of benchmark for us, and I will talk about this. What we know from the first analysis that we did, and I presented this last year here at IPTCom where I was introducing a tool that is coming again in this presentation that is called JATAC, that is a tool for measuring Janus scalability. We identified some bottlenecks inside our stack, and in particular, we identified ICE, which is the protocol that allows you to manage reachability in the wide sense in the internet. We identified ICE, I was saying, as a critical component of our stack, and in particular, one very nice library that most people use today that is called libnice. So we love libnice, but we understood also that there were some issues when pushing libnice functions to the extreme, which is what we do when we try to scale Janus. So that's the main context of the presentation. And I will quickly move to how we organized our trials. I need to provide you with some information about the key features of Janus. Basically, Janus is not a monolithic component. It has been conceived at the outset as a component that has a core, and the core provides the basic WebRTC stack and functionality, but you can plug into the core a number of plugins. And here I'm mentioning some of the most well-known plugins. For example, the video room, which is the selective forwarding unit plugin that I think Ludo was using for his tests. The streaming plugin that is used for monodirectional streaming, broadcasting of multimedia streams across the internet. The audio bridge, which is an Opus compliant audio mixer. And the SEEP plugin, that is the one we started with at the very beginning, which was the one that allowed us to gateway different, let's say, SEEP-based applications towards the WebRTC world. So why am I telling you this? Just because I would like to stress the point that it is very hard to analyze scalability of a component like this, because this is a multifaceted component. And there's no one-size-fits-all approach for that. That's why I'm focusing here in this presentation on a couple of interesting use cases that I will introduce. There's no one-size-fits-all solution because different functions involve different parts of the entire stack. So, for example, if you work on a multi-point control unit, you need to work on mixing, so properly manipulating the streams that you are relaying. If you just use an SFU, you are relaying, you are not manipulating streams, you are just taking a stream and then injecting the stream once again into the flow of packets. And if you do gatewaying, you need to handle each stream independently. If you do a video conference, there's a tight relationship between who is injecting the flow and who is receiving the flow. So it's quite complicating, as I was telling you. One case we are particularly interested in lately is broadcasting, not only because we are interesting ourselves in that, but also because we are doing a lot of consultancy work with that. So for broadcasting, we came out with an idea that we called Soleil, which stands for Streaming of Large-Scale Events over Internet Clouds. Soleil is a sort of broadcasting distribution tree. The important thing here is that you see there is the Janus logo just here and here, which means at the injecting node and close to the end users, so the leaf nodes of the distribution tree. Because in our, let's say, idea, the most important part where you need to have WebRTC is when you capture the flow and then you start injecting it, and when you deliver the flow to the end users who want to leverage their browsers. But what happens in the middle, it's up to you. And we are, for example, in our case, we are leveraging standard, either plain or encrypted RTP transmission, because we do believe that it is quite powerful, and it's the technique that allows you to minimize delay, for example. So, as I was telling you, the streaming use case is an interesting one because it is the one that calls for scalability if you want to reach a wide population of users. So we started with evaluating a single Janus instance, and as I was telling you, this is done in order to have a benchmarking figure and also be capable, for example, if you are called for a deployment in a wide scale of Janus, you know how many Janus instances you need to deploy based on the popularity of the stream itself and on the distribution of the end users. We had some known facts which came from our previous activities, and most importantly, we do know that ICE is our bottleneck. ICE is our bottleneck because there's a very well-known issue nowadays, that is this global lock contention that is introduced inside the libnice library, which prevents, let's say, a fast management of streams when the number of streams keeps on growing. At a certain point, you just get stuck. So we worked on some improvements. We were among the first to propose to the libnice community to patch the libnice library by simply removing that lock. But it seems like that lock was there for some reason. So the people of libnice are now starting to release global lock-free releases of their library. Our patch was used as an experimental feature, and let's say it was used at your own risk. As a second path, we also decided to start building a brand new ice stack, which obviously we call JICE, which stands for Janus Ice. And we are presenting here some preliminary results related to the performance of the JICE stack. JICE cannot be compared as a fully fledged implementation of ICE with libnice, because up to now we just focused on IceLight, the IceLight flavor. I'm not going into the details there, but IceLight is enough if your server is publicly reachable. It's not enough if your server is behind a NAT, for example. So there are some limitations. We set up a testing campaign. The idea was to identify bottleneck associated with the global lock related to the ICE agents, to use these as a benchmarking figure, and then to move from that point a bit ahead and see what we could reach with either the patched version of libnice or the JICE stack, which is a brand new implementation. Okay. One last point was, obviously, we wanted to identify potential further bottlenecks inside our stack. The test bed is done like this. I cannot go into the details here. I will just provide you with some overview of what we did. This is actually what I presented last year at IPTCom. We have this tool that is called JATAC. It takes a different approach when compared, for example, with what Ludo was presenting before. JATAC has been developed in-house by us. It is used to stress a Janus instance. And actually, JATAC needs to be properly orchestrated. So there is a further component that is the controller that is there that can interact with one or more JATAC instances in order to instruct them as of what they need to do when confronting themselves with Janus and stress the server itself. So basically, we have one Janus instance, multiple JATAC entities that can be controlled and orchestrated by the controller. The controller can, in turn, also orchestrate a media source. And in our case, the media source was an FFmpeg generator. I will provide you with some details. In terms of deployment, we use Docker containers. Two Docker containers, one that is hosting the Janus instance under test that has the features, the characteristics that are listed here, and one more Docker container that is hosting the JATAC tools plus the controller plus the media source. Okay? So it's a very simple test bed, and we are giving for granted that network is not going to be the bottleneck. So we have enough bandwidth, and this is needed in order to stress the end side of the system that is the Janus server. Okay, so by playing with JATAC, we have the controller that connects to Janus. We use a WebSocket interface. The controller can listen for incoming connections, and as soon as a new connection arrives from a client, it can take care of properly orchestrating that client. So basically, it orchestrates the media source and the JATAC clients. The media source is an FFmpeg process. We are generating WebM video and Opus audio with the features that are listed here. Basically, it's video is a 720p flow at 512 kilobits per second with 30 frames per second. It is the test RC2 standard testing video. And Opus is a very simple audio beep at 30 kbits per second. We also have one single test probe that is quite similar to what Ludo was presenting, which is a Chrome browser. And this is used in order to properly assess in some way the quality of experience, so the perceived quality. Since JATAC is not a real client, it acts as if it were a real client, but you have no view of the video. You can just collect statistics. We wanted to have a clear indication of the perceived quality, and so one instance across all of the clients is a real Chrome browser. And we compute what we call an experience breakpoint, and I will just dig a bit into details of that in a while. So we stress two scenarios. One is the streaming scenario. And in this case, we generate 100 peer connections starting from 4 different Janus instances. So overall, we are going to have 400 peer connections. We might generate 400 peer connections from one single JATAC instance, but we decided to spread a bit the load just to make the thing a bit more heterogeneous and balanced. The only instance of the Chrome browser is used to render the actual media. And what we do is that as soon as the frame rate of the video that we receive drops below the nominal value, we identify what we call the experience bottleneck. Okay? So in terms of statistics, here you see that we are going to have a drop in the received frame rate, and that's for us the EB, the bottleneck, the breakpoint in terms of quality of experience. Okay, so the results of the streaming campaign, we were interested in 2 main parameters. One is the number of peers that a single Janus instance is capable to serve before reaching the experience breakpoint, because afterwards it can manage other instances, but the quality becomes a bit worse. And then CPU utilization level, in order to see whether or not we were capable of pushing Janus to its limits. So ideally, we want to reach as close as possible to 100% utilization, because we don't want CPU to be the limiting factor. So we want to reach the bottleneck when CPU is completely stressed. Okay, the former parameter, the number of peers, is of particular interest to us because it gives us an idea of the real scalability of an instance. This is the summary of the results. I will be quite quick. With libnice, with this version of libnice, we were able to reach 220 peers, and then we experienced what is quite similar to what Ludo was presenting with one of the media servers before. So a drop down in performance at 220 peers. And as you can see from there, CPU was not stressed, was 41%. So it is a clear indication of that there is something that is not CPU that is preventing you from keeping the pace. With the patched version of libnice, we can reach 360 peers out of the 400 available, with CPU that is around 85%, and with JICE we reach 390, which is quite okay, quite nice for us. Okay, with JICE, the experience breakpoint, by the way, is quite smooth. You can see we could push the limits a bit further. We could have reached 400, but in order to be sharp with determining the real breakpoint in terms of experience, we stopped at 390. Okay, a further scenario that we test is the echo test, which is different because with the echo test you need to somehow manage a single stream that has to be dedicated to a single client that gets connected to you, and you are simply bouncing back things that arrive from that client. So that's why it's called the echo test. With this scenario, I will move to the figures. We can reach the overall number of 400 with JICE. We are quite close to that figure, 380 with the patched version of libnice, and we are at just 140 with libnice. And again, that's the global lock issue. So just a few considerations before concluding. We did know that libnice had some issues for us, so this is not a novelty, but we used it in order to benchmark the 2 alternatives that we are working on. The breakpoint is something that really immediately comes to your eyes when you look at the figures, and it's something that depends on the fact that you are not able to guarantee anymore the throughput that is needed in order to properly serve the clients. And again, this comes from the fact that you are just stuck in a global lock and you're not able to give any power to any of the demanding threads. Okay, this happens at the same time as a clearly identifiable peak in number of not acknowledgement packets that you receive and lost packets. And this does not happen neither with the patched version nor with JICE. This is what I was mentioning. Lost packets and NACs have this steep increase, and this is a clear indication of an issue that you have internally. Okay, so to conclude, a single Janus instance, when it is properly equipped, obviously, with resources, can keep the pace of an increasing number of clients in two of the most compelling scenarios that we need to be capable of supporting. The case when you use libnice is obviously a case where you are penalized, strongly penalized. If you remove the lock, things improve quite a lot. If you use the JICE stack, which again is a very, let's say, premature release of a stack that needs to become much more complete than it is now. But with the JICE stack, we are really confident that we can reach even better performance figures. Just to complete, before asking you if you have any questions, as a side effect of this campaign, we also found a few, let's say, niche for improvement inside Janus itself, especially in the way we deal with the streaming function. And I'm not going there into the details, but just to say that when you work on performance testing, you always come up with nice side effects that allow you to improve your work, even when you were not focusing on that specific function. In the paper, there are figures that are already, luckily enough, already obsolete for us. The latest performance figures are even better and are really promising for the case where you want to really scale the distribution of a wide number of flows to a distributed population of heterogeneous clients. So basically, that's it. And if you have any questions, I will be glad to get them. Thank you. Please.
So obviously, the JICE is a lot simpler code than the libnice. So are you saying that you got better results